Hey, this is Steven from Legit Tech Tutorials and the Green Engineers. Welcome back to my tutorial series on the standby and signing into Trello. Shh. Oh, go to your boards. Okay. So let's talk a little bit more about the DIY Metal Router 2. We're gonna do a little bit more work on it. I kind of put aside the spindle for now. So I'm going to show you a little bit more. We're going to jump in to this guy to show you guys a little bit more of what's going to happen here. But we'll jump on AliExpress to show you a little bit more of some of the structural pieces that will be running this thing here. So let's go ahead and go to the metal router here. Oh, it missed something. Anyways, so here we're going to be using some high wind rails. So this is kind of what you would use on a high rigidity machine. These are extremely stiff and they help a lot with the twisting torques here. And then also this side lifting, and keep everything really, really flat. And because they're bolted along a piece, there's no cantilever. So there's a lot of these other machines, for example, which is one of the ones that I designed before, my other router. My other router was not going to be my DIY router 1 or DIY mill 1 was not going to be rigid. So that's what this is. This has got to be really, really rigid because a few days ago I ran aluminum on a shop bought Buddy, which is a very small machine, and it just was howling and vibrating a lot. So I need to optimize the rigidity of the machine, which it looks like this Trello did not save. Anyway, so let's look at the let's look at some of these routers that I'm talking about. Yeah, so something like this. So originally I was thinking about buying one of these and converting it, but let me show you guys what some of the issues are. Because basically, if you were able to look inside, which I don't think they're even going to show you. So here they have these rails, right? Which, I mean, theoretically, that's fine. But they're cantilevered, right? So there's nothing. So here in the middle, and it twists, you're going to have a lot of movement, especially here with this really, really long chute here. These are all cantilevered out here. Some of them, they have a little rib that goes along here, which, I mean, that's fine, but others don't. So now that I think about it, that would even be okay if we had that as well. But then there's nothing preventing the twisting unless you put it on the other side. So I mean, okay, so here's the rail. So this is a y-axis down here. So it does have this guy cantilevered across, but it does not look like this guy is. So this is good. This is not so good. So, I mean, they do have two supported sides with a ball screw nut. So, I mean, this is a pretty good machine here. How much is this one here? So this is $1,700 for a 6040, which is about 25 inches by 15 inches. And it has manual pulse jogger. Wow. It has a lot of call-outs, and it's got hold downs. Now it's got a fourth axis. So yeah, so basically it's going to be very, very similar to this, except for our rails are going to be here, and we're going to have a mounting solution here for a plexiglass kind of window, so that we could run coolant and it splash up against the window, but yet be protected here. So we're going to have rails run along the bottom here, dual bearing rails. So like, for example, dual carriage. So we have one carriage here, for example, and then this guy bolts to it. Then it's going to come up here, and it's going to go across, and then we're going to have the spindle actually be in between the two of the brackets. So this is going to go up here and kind of form, like it's going to form an I-beam here. Right, so you have a bracket here and a bracket here, it goes across, and then the spindle is going to straddle between those two. And then also 2 rails here, 2 carriages each, a rail here, 2 carriages each on the back side. Back side is probably going to be thicker than the front side. And then this is going to go down, I need at least 3.5 inches there, so maybe 5 inches. So about 5 inches of clearance here is all I need, or then about 5 inches of travel here is about all I need. So it's probably just going to be able to come up to clear this guy, and then this guy is probably going to have 5-6 inches over it. And then this is a 3 horsepower about. Prepositional accuracy 0.03. Yeah. 65 kilos. So let me send a text here. Sorry about that. Okay, so here's like aluminum extrusion again. Here's the issue. This is cantilevered. I mean, you're gonna have cantilevered, but the parts that this is gonna have a dual aluminum. So everything, this entire machine is gonna be made out of aluminum, just for ease of machining. I might even be able to make it out of steel. Steel's a little bit harder to machine and square up and do a lot of that stuff. Because again, the idea with this is going to be I buy a lot of Mike 6 plate. And the Mike 6 plate is already going to be tolerance on top. It's already going to be flat. And basically what's going to happen is we're going to go in there with the machine. And the machine's going to actually face the plate first. And then actually cut the T slots into it. So basically it's going to make its own table, so that everything is already in line with the actual machine itself, and everything is the right depth from the head, so everything's trammed. Everything is trammed and aligned with the head, so everything will work properly. So we're going to use some high wind rails. We're going to use some aluminum plate probably. We'll have to look at the stresses, but that will allow us to move the machine around quite a bit and ease of machining this stuff. But again, obviously we have aluminum machining steel, mainly steel and some aluminum, so that might also be something to think about. So, and also we're going to have to have support 4th axis with a tailstock. So let's go ahead and get started here. So let's go ahead and go back here. We got, there are 20 minutes here. So let's jump into DIY router 2. Okay, so let's say that this is this guy here is the bottom. So we're gonna call this the base. So basically the base is gonna be, as far as what I'm thinking, a plate of giant Mike 6 aluminum. So it's already been faced, even though it doesn't necessarily need to be faced, but we want the side to be flat. So I don't know, maybe we don't even need Mike 6, but let's take a look here. So okay, so now because it's this style and not a VMC style, VMC mill, because a VMC mill has a lot of losses as far as area. Because the center spindle stays stationary as far as the X and Y axis and just moves on the Z, you need to have double the travel on. You have to have double the travel than what you're actually going to get. So basically, if you have this point, if this is where your spindle is, your entire build volume for your Y has to be able to go over here and over here. So, for example, here, right? So let's say it's, say that this is 12 inches just for looking at it. Let's say it's 12 inches. Okay, so right here, you want, basically your entire travel is 12 inches, but you need to get your entire bed over here and then your entire bed over here in order to be able to cut that entire volume. So you actually have 12 inches of travel, but you only have 6 inches of travel on the actual. So you're actually cutting only 6 inches, but your plate is moving. Your plate is moving. It has a 12-inch throw on it, right? So let's say your point is here. You have to move from here to here. So it's like you get my drift. So for example, here to here, here to here. And so let's say from here to here, so yeah, it's 6 inches. So it does indeed have to travel. So it does indeed throw 6 inches, but if you're looking from edge to edge, it's actually moving 12. Now, with the spindle here, with this style where the spindle moves all X, Y, and Z on a carriage, on 2 carriages, it has the X carriage, right? It has the X, 3 carriages almost. Well, I guess you could call this 2. So this is this carriage, and it's also the carriage that moves on the Y. So X, Y, and then this got another carriage that moves Z, and the bed stays stationary. So depending on your diameter of your spindle, so let's say your spindle is, let's see if we have, does it have size, spindle here? Basically, let's say the spindle is about like 2.5 inches in diameter. So basically what you're going to have is, if you see here, it's going to come over until it hits the side. So let's say here, let's say a tangent here to here and tangent from here to here. So let's look at an actual one. So let's look at a 0.8 kilowatt. Okay, here's an 800 watt spindle. Size is 65 millimeters. Okay, so it's about a little bit over 2.5 inches. So basically now it's hit that plate over here. And obviously it's going to have something around it. So let's say, let's delete this and delete this. So let's say that we have a offset. Say we have like a 1/4 inch plate around it, 1/4 inch plate of aluminum. Holder around it, and then it's straight off here, bolted to this other carriage. Okay, so that's there. Let's create another one. And let's do tangent here to here, from here to here. All right, so let's go over here to the Trello, and then I worked on the Green Machine Metal Mill. So my cabinet that this guy sits in has a 25-inch length and a depth of 20 inches and 20 inches tall. So a depth of 15 inches and a height of 20. So we can't go farther than 15. I mean, than 25. So let's set this at 25. So this is the maximum table size here that we can possibly go. So let's see, what can we cut here? So this is 22, about 22 inches. So what is that? And that's all assuming that this is the height. I mean and let's say that obviously we're not going to get exactly here because the plate's going to be back here, so that's where this guy's going to be. So I'm going to say we will probably get 19 or something. We could probably get 19 out of it. Alright, so, well, we could look right now practically. So we have about 22 divided by 25. So this is 88% efficiency of space compared to the other one, which is obviously 50% usability of space, because you need to have the entire thing over here, entire thing over there. 1 second, text. So, yeah, so about 88% efficiency. So let's go ahead and, so this is good. Now, what about, okay, so what about here? Oops. Set, default view. What was it, 0.55 millimeters? I mean, 55 millimeters? No, that's not it. 65. Offset, 1/4 inch. So let's go ahead and set this here. What? Oh, we'll just do this then. Anyways, it's basically going to be same deal, 88% of 12. It's 10 and a half. So here, again, I don't need that big of a requirement here. I just want to at least use the entire table all the way back. But it's harder, it's gonna be harder to clean back there. I'll have to move the cutter in and out. But again, that's why I want it to go all the way up so it clears the gantry, so it doesn't come down underneath the gantry. So I go in there and use the vacuum cleaner. So yeah, let's start out with this size here. Let's go ahead and close out all this stuff. And then what I'm going to do is let's go in here and let's change all this stuff to construction line. All right, so let's say here, all right, so let's look at these high wind rails. So let's duplicate this. I'm gonna say you probably need about half an inch thick. I mean, about an inch thick. Okay, so we have some different lengths here. That's probably going to decide what we have. So, I mean, we could always cut it. Yeah, I'll just cut it. So we have 500, 550 millimeter. That's 22 inches. So right there, we buy that one, we cut it. And so that one is, where is it? This one here. That's, see, here's all the dimensions, but what's the overall width? So this guy's a little small. Yeah, it's GN5. GN5C. 12C. GN12. There is WGN12. So yeah, this is a bigger, way bigger block. 15's way bigger also. So probably gonna go, what about a 15? So let's say 15C. The width of the block is 32 millimeters. 32 millimeters. 32. Oh, that's a big block. Which, that's fine as long as our bolt's clear. So it could be that big. But what about the rail itself? So that means that this thing has to be bigger than that. And here's the issue, is how will this clear an 1/8 inch down here? Height 1. H1. 4 millimeters, which is above 1/4 inch. Above 1/8 inch. So we have to recess all those bolts inside. That's fine with me. So let's go with that. Let's go with MGN 15C. MGN 15C. Oh, these are big boys. 550. Wow. Oh, this is really small. I think I just looked at this one, yeah. This is a way better picture here. So let's look here. Dimensions, mounting bolts. So static load, we get a way higher static load here. Moment, way higher moment. Everything's higher. The 12, about 3 times higher. About 3 times higher, about 3 times higher, about 3 times higher. A little bit over 3 times, but yeah, use the entire block there. Okay, so yeah, let's look at the 15C. Oops. Yeah, look at these big boys. These are dual. So yeah, we want the decent sized carriages. I mean, they're going to be really close together anyway, so it doesn't really matter. But it looks like they have so pretty cool. So basically, I think they just look like this. This 15C, 15H. So look more into those. But yeah, let's go ahead and look at this aluminum plate. So what do you have as far as weight here? This is just 6061. $6061 aluminum. Properties. Whoa. 468 divided by 12. 39 pounds. 39 pounds of Mike 6. Not gonna be cheap. Again, the big thing is that we go with this router, and we go and face it so it's plumb everywhere, so we probably don't even need Mike 6. This guy just has to be extremely straight, but I go on a mill and straighten that out. So basically we're going to have some holes drilled here where this actually we could even off-center it where we put it here, and then that way we have a little bit more space where we could put the bolt holes for the sidewalls. And then put some slits in the sidewalls so they slide down, and then some sort of seal that we could slide over for the corner, so that when it's flinging coolant there, it'll be nice. And then another thing, which we can't really do, but I would like to cap the T's at the end. So come in and cap them, cap the T's. Alright, so let's go ahead and do that really quick. So actually we'll do that in the next video. So this is our base. We're going to have little feet coming off the bottom here. And then we're going to drill, and then there's going to be holes drilled in here for the different the different positions for the for this mount over here for this guy. So these different hole patterns. Which E is basically the gap between each one. So E here, 15C is about 15 millimeters apart. So let's look at that really quick. So about that, so we'll have 0.6, and this is 25. So we'll have we'll have 42 bolts per side, 42 holes per side, with this guy sitting straight up. So that's another thing why we would want Mike 6, is Mike 6 is already ground here, so when we hold on to it, it's already straight up. Because we're going to put this in a mill and then have it going straight up like this, go down this section here, so that they're perfectly spaced, either on the manual mill or on the Tormach. I'm thinking if they're like this, probably going to be on the Tormach to do that at the shop. Before the shop goes out of business, we need to complete this project so that we have access to the machines to complete what we're trying to do. Alright, so I'm going to go ahead and take a break. That's it for this video. Thank you guys so much for watching. We're coming to the end of 30 minutes here. And this has been Steven from Legit Tech Tutorials and the Green Engineers. I'd like to thank you guys for watching. If you like this video, please subscribe for more videos like it, and I'll see you guys in the next video. Thanks for watching. Take it easy. Peace.